Now the potentiometer is placed in the front panel, and my plan was to make the ribbon cables from the potentiometer to the board, but I realized that I have only this one in stock, so I have to wait a couple of days for a delivery of more ribbon cables. Then was the plan to connect the potentiometers and connectors and so on to the board and check that everything works. So I haven't managed to destroy something during this exercise. There is still a dummy knob here, and I made a Google search of the Blackstar Fly schematic, and I found a site called midboost.com published and analyzed the schematics, and that opened up some possibilities which I will come back to later when I tried it. As you can see, these potentiometers here are double potentiometer. One is for the tone control and another one for the delay. And for the delay, it's actually a digital delay circuit from Princeton technology, which was intended for karaoke machines, but it's used in many guitar pedals today. The double potentiometer here, one of the resistors control the delay itself. It can vary from about 40 milliseconds to 400 or 600 milliseconds, and the other resistor control the feedback. So the feedback will increase with longer delays, and that I think is to avoid flutter echo. But actually with such a wide range of delay, it can mimic both spring reverb or tape echo machines. I can consider to use another potentiometer to maybe control the feedback separately. Another possibility is the tone control. It's called ISF, infinite shelving or shape filter or feature, and it's actually a frequency dip in the mid, which you can control the frequency, so it can vary from, let's say, 500 to 1K. And the idea, according to Blackstar, is that you can control this dip or notch from something which is like American Amplifier, Fender, Boogie and so on. Their tone stack have this dip at 500 Hz, and British amplifiers have it around 800 or something like that. And this tone stack have a possibility to also, by do some change of components and so on in the circuit, I can add an extra potentiometer and choose if I will control the highs or lows and or the mid itself more accurate if I want to add more treble, for example. And then I can put in an extra potentiometer here. By the way, Blackstar has filed a patent for this circuit. I don't know if they can manage to have a patent approved for just a mid control, but good luck. I thought about a little side project, and you see this rocket switch is illuminated, but it's only for 200 200-230 volts, as it is a fluorescent lamp inside. So I consider to see if I can put an LED instead, because the power supply I've chosen is 7.5 volt power supply, and I will use one of the jacks here, and that will feed the board where it's a stabilizer which feed all the electronics with 5 volts. So I try to open up this. There we go. And inside here you can see that it's a fluorescent lamp and a resistor, and they are connected to this spring nails who maneuverate the switch itself. So I plan to replace this with a resistor for the LED. This is an old LED I found. It's probably a Hewlett and Packard. To calculate the value of this resistor for the LED, it's quite easy. I use I plan to use 7.5 volt, go from the jack direct to the power switch. So I will have 7.5 volt, and LED is around 2 volt of voltage drop, so I will have around 5.5 volt over the resistor, and with I think 5 milliamperes is enough to have this shine bright. So 5 volt divided by 5 milliamperes, that is 1 kilo ohm. So that is my choice. See if it works. Besides the curiosity to know how this loudspeaker works in the Blackstar box, I can figure out with the volume of the cavity in the Marshall fridge door if it's possible to reach the same performance. It's always sensitive which volume of the box behind the loudspeaker has, and other behaviors to know the low frequency response. So I did some measurement to see the parameters. It's made by measure the impedance, so I have to remove this board or to reach the driver itself, measure the impedance, and then do a so-called delta mass measurement. I add some mass to the cone and make an impedance measurement again, and from that the Thiele-Small parameters could be extracted. Thiele-Small parameters is a bunch of parameters which transform the mechanical parameters into electrical. So the whole loudspeaker can be analyzed as an electrical circuit, and in such way it can be simulated in different boxes and ports and so on. This is the schematic I use for measuring the impedance of the loudspeaker driver. The signal comes from the sound card through this resistor, and here the loudspeaker is connected and the device under test. The voltage is measured on the right channel here, and the current is measured over this resistor, so that's the difference between the left and right channel. Here is the loudspeaker, and with the delta mass type of Thiele-Small parameter, I will first measure the loudspeaker and then attach pads, in this case 3 gram, each square have 1 gram. This is the result of the impedance measurement. You can see the resonance here. And then I do a second measurement and have added the 3 gram to the cone. And you see this is as a dotted line here. So this too is required, and then we can start to make the Thiele-Small parameters. Looks like this. This is made in an old software called Audio Capture. It's not available anymore. But the 3 most important parameter for be able to simulate a vented box, that's the resonant frequency, the VAS, which is a measure of the spring effect or the complements of the loudspeaker, and QTS, which is the total Q value. It's a measure of how resonant the driver is. And taking these 3 values to the box design, and then we choose the vented box, and with a 1 liter box and a port like this with a diameter of 15 millimeters and 2.5 centimeter long. We can see that we have added the port resonance here, and we have stretched out the frequency response to approximately 80 Hertz. The Blackstar box have 1.3 liter, so we simulate that volume. As you see, the Blackstar box is very well designed. But in my case, maybe I don't have this space to cut out so much of the foam, so I can reach that. So we will see what happens if I reduce it to 0.5 liter. It looks like this. So I can only expect down to about 200 Hertz instead of 80. So maybe I have to dig out more of the foam to reach the same response. Here the driver is in place in the Marshall fridge door, and I have put my measurement microphone just over it, and it's connected to my sound card up here to be able to measure the frequency response of the driver and the port here. I use the software Live Capture Pro, and here is the result. The green trace here is the frequency response without the port, and it's quite flat. It's really good up to 5K, which is enough for guitar use. And if I open the port, I got a little bit improvement here. So it's not as good as the Blackstar box, but I think it's okay for my use. I will also do a review of the circuits used here. It's very well designed, and I will go through some of the features of this circuit who are used here. Take a look at this block diagram of the Blackstar Fly 3. We have the input buffer, which convert the high impedance from the guitar. We have a clipping circuit and an overdrive circuit, which can be enabled with the switch button. We have the filter and tone stack here. We also have some filtering before the clipping, and then some more filtering before the delay and reverb. And then is a mixer and so on, which I don't use here. And then is the Class D amplifier. So beside the filter and tone control, and of course the loudspeaker, the clipping circuit and the power amplifier are also very important to give the desired guitar sound. This is how the gain and clipping stage looks like. As you can see, it's an active soft clipping circuit. This should be double diodes, and the gain can be adjusted here to over 40-45 dB gain. And actually you can also notice that there are no asymmetrical circuit here to mimic triode tube preamplifier stage. In my opinion, I think that this second harmonic distortion will be masked by the speaker distortion anyway. So, and after that, there is a tone control circuit to equalize this distortion, which can have been generated in this circuit. Actually, this circuit is very close to Ibanez tube screamer. After the gain / soft clipping circuit, there is an overdrive circuit which can be kicked in by a switch. So more gain will also be added. I use the standby switch at the fridge front panel for this overdrive. The circuit is very close to a Boss Distortion 1. These diodes will evaluate an overdrive and tube power amplifier. But it's not actually the tubes which makes the extra sustain for the guitar, but the output transformer with its flyback pulses which give the extra 6 dB gain. This can be emulated in transistor amplifiers, but it requires a headroom of the power amplifier or peak power up to 6 dB or 4 times the power. As you can see in this graph, these flyback pulses produced by the output transformer requires at least twice the voltage if they should be reproduced by a transistor amplifier. And twice the voltage, that means 4 times the power. So to be able to emulate a tube amplifier of 100 watt, it requires a transistor amplifier of 400 watts. The last piece in the electronic chain is the power amplifier. It's a Class D amplifier, which means that it uses pulses which varies in width, and then will be recovered in a filter resulting in an audio wave. So this is the pulse width, and this is the audio wave. The benefits is high efficiency, about 90%. Compare that to a standard Class AB amplifier, which has 60% at the best, but usually only 30%. So most of the available power will be wasted in heat. The circuit used in the Blackstar is the PAM8304, and this is a full bridge circuit, so it gives 6 dB more power, or 3 watt instead of 0.7 watt for a corresponding Class AB amplifier. Some conclusion about the Blackstar Fly 3 amplifier. It's a very well designed guitar amplifier, and or you get a tube screamer followed by a distortion pedal followed by a tone stack, which can be varied between a Fender and a Marshall tune, a karaoke reverb, and a very efficient power amplifier which drives a 3-inch loudspeaker in a 1.3 liter box. Thank you for watching.